Welcome to the IDSS-Targeted Threat Messaging course. This is Unit 5, which focuses on how to downscale threat information prior to and during impacts from flooding due to excessive convective rainfall. This module will use a few cases to illustrate how to recognize and provide targeted threat messaging for potential flood hazards during the watch and warning periods. Let's look at the rainfall event over eastern Missouri on July 26, 2022. WPC's excessive rainfall outlook had a slight risk of excessive rainfall over the northern half of Missouri from St. Louis northward. A flash flood watch is in effect north of I-70, which is highlighted by the arrows across central Missouri, where the QPF had 1.5 to 3 inches forecast, with lighter amounts in Columbia and St. Louis. During the early evening, this graphic is sent by the local office, focusing on heavy rainfall potential along and north of a Columbia to St. Louis line, with potential for a band of 2 to 4 inches with locally higher amounts. During the next 2-hour period, from 3Z to 5Z, convection develops near the I-70 corridor. Here's a GraphiCast image sent at 10 p.m. local time, showing the developing band of convection. The 3Z surface map shows a surface boundary well to the south across southern Missouri, suggesting the developing convection near I-70 is elevated above a frontal inversion. What about higher up, around 850 millibars? Here's a short-term 850 millibar forecast from the 3Z RAP, showing south to southwest flow converging along the I-70 corridor, with these plots suggesting isentropic lift there to support convective initiation. Here's the 850 millibar forecast from the 0Z NAM, showing the same thing with a band of intense lift along the I-70 corridor, likely responsible for the convective initiation that's occurring. The 0Z NAM shows a training band of convection where the watch is located across the northern part of Missouri, well north of the I-70 corridor. The 3Z RAP focuses heavy rain there as well, but also hints at a band closer to I-70. Here are the mandatory levels valid at 6Z from the 0Z NAM run. At 925 millibars, we see an elevated frontal surface getting closer to the I-70 corridor of central Missouri. At 850 millibars, we see a low-level jet there, promoting low-level convergence from north-central Missouri to the St. Louis area. At 700 millibars, we see a weak shortwave moving across northeastern and central Missouri. We don't see this up at 500 millibars with broad west-northwesterly flow across the northern half of Missouri. At 300 millibars, we have a jet streak over northern Illinois with potential weak divergence in the right rear quad over Missouri. Here are a few SPC mesoanalysis page plots, with most unstable Cape in the left showing decent elevated instability across central Missouri, with more stable conditions over far northern Missouri. Deep moisture convergence is focused on the I-70 corridor and areas north, as shown on the right image. Here we see precipitable water on the left, showing anomalously high values across central Missouri. Heavy rainfall events often occur within this gradient, but close to the max values, in this case likely being north-central and east-central Missouri. The right image shows west-northwest oriented upwind propagation vectors, close to the same orientation as the steering flow aloft, suggesting potential for training convection. Here are the simulated composite reflectivity plots from the 4Z HER run. It still shows a band of heavy storms over northern Missouri, but it also suggests another potential band close to the I-70 corridor. Its 12-hour QPF shows a band of 3 to 6 inch rainfall from north of Columbia to just north of St. Louis, suggesting potential for excessive rainfall from a training band of convection. Going back to the IR satellite image through 430Z, we don't see much over far northern Missouri, do we? We see the actual convective band setting up from north of Columbia to just northwest of St. Louis. However, due to parallax, this band is actually a little south of how it's displayed on the imagery. Let's see the evolution of this convective band on radar. Here we see radar imagery from 3Z through 5Z, showing the band that has set up from Columbia to St. Louis. This band is oriented parallel to what the propagation vectors suggested, with cells moving in that direction, indicating potential for training cells. So we have a band set up on the north side of a high precipitable water axis, with a southwesterly low-level jet helping to fuel new upstream convection. This is confirming what the 4Z HER was suggesting, except with it being just set up a little south from Columbia to St. Louis, with not much yet further north. Are you thinking it's time to start targeting a flood threat message? Often, flood threat messaging in the form of warnings don't start until rain exceeds flash flood guidance, but by that time, flooding may already be initiating. We want to start messaging to partners and the public well before that point in time. At 5Z, radar estimated rainfall amounts show 1.5 to 3 inches, below flash flood guidance, while we may be early in the event. What can we message now on social media in terms of potential for excessive rainfall from this training band of convection? Here's what I would do, using the same PowerPoint template as we used in Unit 4 that focused on severe convection. As with Unit 4, this is just an example of what could be done, with other correct solutions possible. I'm focusing on the area from Columbia to St. Louis through 3 a.m., and I indicate a high level of confidence in this hazard given the current radar display. Everything appears set up for a flood event, but the main question being how significant, based on how much rain accumulates before the pattern breaks down or shifts to another area. Here is a 12:45 a.m. update from the St. Louis office. We see an established band of convection with cells training over the same areas. The message primarily focuses on what is happening and not necessarily what is expected, other than potential for flooding. Look at what is headed for St. Louis. We can focus downscaled messaging for any part of this region of heavy rain. For this case illustration, I'm going to focus messaging on the St. Louis metro area, where rainfall amounts are approaching flash flood guidance in St. Louis, but exceeding it in areas west-northwest of the city. I would likely message partners in the St. Louis area, the biggest population center for the office, with information about the increasing threat of flash flooding for the metro area. I could include a graphic through Slack that shows a radar animation, or perhaps a radar rainfall estimate, highlighting the threat. In addition to this, if it's possible to call key partners at 3 in the morning, that would be a good idea as well to reflect on the potential seriousness of this situation. Direct calls, messages, graphics are all options for downscaled threat messaging. Here are the radar images from 5Z through 7Z, thus through 2 a.m. local time. This shows a lengthy period of heavy rain over the same areas. In fact, 3-hour radar rainfall estimates through 7Z show a band of 3 to 5 inches northwest of St. Louis, with rainfall to flash flood guidance ratios approaching 1.5. By 7Z, the training band has become established over the St. Louis area. A dangerous situation has developed. With the heavy rain continuing over the impacted area, time to strengthen the targeted message for areas between and including Columbia and St. Louis. This message goes through 5 a.m. with high confidence of flash flooding in the threat area shown. At 7Z, 2 a.m. local time, flash flood warnings are issued for areas of eastern Missouri, including the St. Louis area. However, can you tell from this message that St. Louis is in immediate danger of flash flooding? It's there, but hidden a bit. Even on the Twitter graphic, the warning area is pretty large. It's hard to tell where within the polygon that flash flooding is most likely to occur, at least not without radar imagery. Through 8Z or 3 a.m. local time, radar shows this persistent convective band sitting over St. Louis with more convection upstream. What would you tell partners in the St. Louis metro area? I would send a quick chat to partners focused on the biggest population center and the potential impacts. With Slack, I could include an image showing radar rainfall estimates across east central Missouri, or a radar animation showing persistent heavy rain over the St. Louis area. I could also provide that image in a social media post. This is a dangerous nighttime event, and we want to try to notify whomever we can of the danger of driving across the threat area. Radar from 3 to 4 a.m. indicates very heavy rain continuing to track across the St. Louis metro area, and is likely to continue for a few more hours. There is some heavy rainfall elsewhere, but the main event now appears to be across the St. Louis metro area, where we have a training pattern of heavy convection. Note this flash flood statement, issued at 3 a.m., that indicates multiple roads not being passable in St. Louis. 3-hour radar rainfall estimates through 4 a.m. reveal a dangerous situation for the St. Louis area, with 3 to 6 inch rainfalls, and 6-hour estimates of 4 to 8 inches, as much as double flash flood guidance values. I would continue to message the progress of the event to partners. Here's another example of a partner chat message focused on the St. Louis metro area that could include a rainfall image. Focus is on the what, where, and when. A major flood event occurred in St. Louis. Here you see a flash flood emergency for the area, with reports of water up to the top of multiple vehicles. Given the environment that was favorable for training convection and how the radar pattern evolved, did you see opportunity to message this high impact potential well before receiving flooding reports? Here is the event rainfall for this case, with 8 to 12 inches across eastern Missouri, including the St. Louis metro area. Here are some articles focused on this disaster, a pretty amazing event. The pattern aloft was fairly subtle, but there were important clues of the potential for a training convective pattern that could set up along the I-70 corridor, even though the high-resolution models did not distinctly show that result. Let's try another event across southeastern Illinois on August 1st, 2022. WPC has a marginal risk of heavy rain over most of Illinois, with a greater potential further east. We have no flood watches across Illinois. Also note that SPC has a marginal risk of severe weather over southern Illinois, with a severe thunderstorm watch in effect. We actually end up with a swath of large hail in this event over southeastern Illinois, so this is a different type of environment than the prior case, and likely will be a more challenging case for us. Here are some 24-hour QPF forecasts from the GFS and European models. Nothing too exciting here. The Euro hints at just over an inch of rain in southeast Illinois, which is not shown by the GFS. Let's look at what the CAMs are forecasting. Here are 5 different models. The HER and high-res NAM suggest potential for heavy rain in southeast Illinois and southwest Indiana. The other CAMs show potential for convective rain in southern Illinois, but amounts are not impressive. Of course, one should not try to forecast heavy rainfall solely based on model QPF forecasts. So let's look at the ingredients we need for heavy rain. Here are some plots from the 20Z run of the SPC mesoanalysis page. Mandatory level data for 20Z show a moisture boundary over central Illinois at 850 millibars, with broad northwesterly flow further aloft over Illinois. We see evidence of a weak shortwave moving across central Illinois at 500 millibars and 300 millibars. Unlike our first event, which focused on elevated convection, this event has intense, potentially severe convection, given large instability with sufficient deep layer shear. Note that the cloud layer mean wind is oriented southeasterly at a decent speed. At first glance, this looks more like a severe storm type environment than an excessive rainfall one. Here are some heavy rain fields from SPC's mesoanalysis page for 20Z. Precipitable water values are lower in this case compared to the prior one, with the axis of maximum values over south central Illinois. Notice that the upwind propagation vectors are oriented northwest to southeast, parallel to the storm steering flow aloft. Could this support training convection? Here is the precipitable water forecast from the 21Z WRAP run. Notice the axis of maximum values over southern Illinois, with a slug of lower values advecting southeastward across central Illinois in the wake of a passing weak upper shortwave. The 21Z surface map shows an axis of weak convergence across central Illinois, along and south of which exists an area of very high dew points in the upper 70s, supporting an extremely unstable air mass. Thus the hail threat, right? Visible satellite imagery shows a narrow band of enhanced cumulus clouds oriented a bit differently than what we see on the surface map. However, it is oriented along an area of weakly converging flow at 925 millibars and 850 millibars from far northeast Missouri into southeastern Illinois. Note on the 1940Z image the annotations showing the location of a weak upper shortwave trough, subsidence coming in behind the trough, and the lack of any meaningful forcing mechanism for convective initiation over southern Illinois, and with that, very little cumulus. So these images seem to pinpoint the axis of enhanced cumulus, particularly the part ahead of the shortwave, as the favored region for convective initiation during the next hour or two. At this point, I could design a social media graphic that indicates the area of heavy rain potential over southeastern Illinois, with my graphic valid through 6 p.m. I indicate a low-end moderate level of confidence, not higher, since we don't have any storms yet and uncertainty is still considerable. This is my area of concern for the late afternoon and early evening hours. The 21Z HER is pretty interesting. It shows initiation of convection along a weak surface trough in the eastern part of south central Illinois. The convection is forecast to move southeast given the cloud layer mean wind, but the HER hints at the potential for new convective initiation upstream. As a result, the HER forecasts a 12-hour QPF maximum of 3 to 6 inches across a portion of southeastern Illinois, where it forecasts the most persistent convection. That's interesting. Here are visible satellite and radar images over the next 1 hour period. Convection develops in the vicinity of the surface trough, east of the upper trough axis, moving southeast across southeastern Illinois. So how do we expect the radar display to evolve over the next few hours? Given the taller convective tops on the western side of the cloud mass, and with enhanced low-level westerly flow impinging on the convection, it appears there is potential for new upstream convective development along this cumulus band. Given the apparently sufficient clues to indicate potential for heavy rainfall, if we see a cluster of storms train over the same area, I would design a 21Z social media graphic like the one shown here. My confidence would not be high, again due to uncertainty as to whether we see an excessive rainfall event or just scattered severe storms with hail. I might also share this graphic using Slack with core partners, along with a message similar to what's given in the What's Expected section. Here are visible satellite images every 30 minutes from 21Z through 22Z, and hourly radar images from 20Z through 22Z. What do these images show? Satellite imagery is most revealing in not only indicating initial convection moving across southeastern Illinois into southwestern Indiana, but also signs of new convection just upstream, which could lead to a small-scale convective training pattern over southeast Illinois, as was hinted by the SPC mesoanalysis page graphics we previously viewed, as well as the 21Z HER. At this point, 3-hour radar rainfall estimates show 2 to 3 inches, approaching flash flood guidance, although there could be some hail contamination with this. So my confidence is increasing, given trends in satellite and radar, and based on my understanding of storm environment. I'd still have a hard time going high confidence, only given how much this looks like a severe storm environment. And there could be complications from large hail and strong outflow winds that could interrupt a training band of convection over the same area. Nevertheless, everything seems favorable for training convection. Thus, I'm downscaling my message to the area where radar is showing persistent heavy convection and mentioning potential for multiple storms to track over the same area, leading to flash flooding in the highlighted area. I'd also share this in an NWS chat message with core partners. This graphic covers the period through 7 p.m. local, or 0Z. At about the same time, a flash flood warning is issued for my target area of Jasper and Richland counties, with up to 4 inches of rain expected, exceeding flash flood guidance. Here we see visible satellite and radar images through 0Z. Simply compare the 22Z radar image to the 0Z image, with heavy convective rainfall over the same area for at least 2 hours. On satellite, notice the new high cloud tops on the western side of the convective cluster. New upstream development is causing the cluster of propagation vector to be opposite of the steering flow, thus yielding a cluster with minimal net motion. Flash flooding is likely resulting. Here's a quick NWS chat message I would send to partners in Jasper and Richland counties in southeast Illinois, focused on the developing flash flood situation. In Slack, I could also include the radar rainfall estimate, which I could also share on social media. I would likely send an update, at least hourly, focused on how the threat is evolving, and downscaling where impacts are most likely occurring. 3-hour radar rainfall estimates through 0Z reveal a small area of 3 to 6 inch 3-hour rainfalls, at least double flash flood guidance. A pretty small scale but potentially significant event that we focused on using mesoscale environment analysis and communicated through targeted threat messaging. Rainfall for this event is shown on the right, with an area of 6 inches or more occurring over portions of Jasper and Richland counties in southeastern Illinois. Here's a news article about the event. What is challenging about this event is how small scale it was, and one that involved both excessive rainfall and large hail. Our focus was to message the threat before the event occurred to provide lead time needed to protect life and property. Do you see how this is possible through targeted threat messaging? Even for the more challenging small-scale events like this one. Not easy, but incredibly rewarding when successful. So in summary, this module focused on targeted threat messaging during the watch and warning periods for excessive rainfall events that yield flash flooding impacts. 2 cases were presented that illustrated how to utilize storm environment and radar imagery to target messaging on where excessive rainfall would likely occur within a larger watch area, or even for small-scale events with no watch at all. The cases focused on trying to target the message prior to the heavy rainfall occurring to provide lead time ahead of flood impacts. Keep in mind that lead time relates to the range of decisions you're supporting. Thus, greater lead time even through targeted threat messaging, supports decisions beyond just taking immediate protective action. These cases were used to show how targeted threat messaging can provide more accurate and timely threat information to support actionable decisions. It focused on social media graphics as well as NWS chat messaging. An example template was utilized for social media graphics as a suggested approach to illustrate what could be done in an efficient manner. The cases indicated that one needs both good science and solid, efficient communication to provide effective targeted threat messaging. Thank you for completing this flood-focused case examples module.